Well, hello and welcome, and this is Dr. K, and today we're going to talk about rule number 1. Alright, so today we're going to talk about rule number 1. Sometimes it's also referred to as the enveloping principle. And what this means is that when we have a part that we're going to produce, we must control the form of the part within the limits of size. So what's that really look like? So let's take an example here where we're going to have a cylinder. And that cylinder is going to have some sort of feature of size, and that feature of size is going to have some limit of size. And so we can notice here this is a shaft, and it has a feature of size, our cylinder. If you're not sure what a feature of size is, look back at some of the other videos that I have on feature of size. And there is a limit of size that's going on. So what rule number 1 says is that when we create this part at its maximum material condition, right, that's that symbol M, maximum material condition. And for this part, it's a shaft. Its maximum material condition is going to be what? Let's get our diameter. It's going to be at a diameter of 10.1. When it is created at 10.1, we need perfect form. Perfect form. What's that mean? Well, that means this part, this feature here, has to be perfectly straight when it's created at maximum material condition. Now at least material condition, remember what that is. It is the smallest part. So what's that going to be? That's going to be a 0.9. We have no requirements for perfect form, but we do still have to fit inside this envelope. And so here's the example that you'll commonly see. If this is our shaft, and what I have here is kind of a half block gauge that's showing us this 10.1. So this is our 10.1 and it's perfect. If we build the shaft, so here we have our shaft, we've put it together, we've built it, and it's created, when we measure this, it measures 10.1. It has to be made with perfect form. Now, if we take this same part and we produce it at 0.9, it's allowed to deviate in form. It's allowed to bend a little bit. Now it still has to fit. So here we go here, we can see our example here. It still fits within the envelope, and that's why we do get the idea of an enveloping principle. It does fit inside that envelope, but it is created at that least material condition. Now, when you take a part like this to make sure that it's correct, not only does it have to fit inside this envelope, but we would also need to measure this size and ensure that it is at least this 0.9. So rule 1 applies to our features of size, and so we have to know that, and we need to be even a little more specific than that is that these features of size need to be regular features of size for rule 1 to apply. Now, one of the rules that it goes alongside rule 1 that we have to remember, and it's one of the most challenging by definition, rule 1 does not control the location, orientation, or alignment between features of size. So what does that mean? Well, that means if we look here at a drawing like this, to where we have essentially many features of size, and as we look here, we can start identifying those features of size. We have these circular features. We even have planar features as we look here, all being features of size. Now, this as a drawing is still incomplete because this information is not enough information for us to control the location, orientation, and alignment between these parts. And if we think about that for a little bit, there's some very strange things that can happen. All right, well, that's all I have for rule 1. Remember, it's Rule 1, the enveloping principle, we're going to be dealing with maximum material condition on the part or least material condition on the part. As we deviate from maximum material condition, our form is allowed to change to get away from perfect. This only applies to regular features of size. Well, I hope this was informative and helpful. Thanks for watching, and I'll see you next time.